Alrighty, in this video we're going to do the practice test. Just some practice type problems that you're going to see on the test that's coming up. And remember, this section covers 3 sections: P4, P5, and P7. We did not do P6, so don't worry about that on the test. And let's look at example 1 here. Remember, I always stress in class, read the directions. So the directions here, the directions you see in the book for the exercises, I use those on the practice test, I use those on the real test, and I use them in all the examples in class. So factor out a common factor. So if I look here at my first term and second term, 5y and 30, what is common to both? What can I factor out? Well, I can factor out a 5. And this was a 5y. If I factor the 5 out, if you think about it as division, 5 divided by 5 is 1y, or 5 times what here would equal 5y. Well, that'd have to be a y. And then we have minus. You could think about it as division. 30 divided by 5 is 6, or what goes here, 5 times what would equal 30? Well, that would have to be a 6. So there we factored out the common factor. Number 2, same directions, factor out the common factor, and we've done several of these in class, in the team practice problems, and in the homework. Think about a big set of brackets here. Underlined in red is our first term. Underlined in blue is our second term. What is common to both that we can factor outside of the brackets? Well, that would be a quantity, x minus 5. And then what would be left inside? If I factored out this x minus 5, the 3x remains inside. And then we have plus. I factored out this x minus 5, so there's an 8 that remains. So the quantity x minus 5 times the quantity 3x plus 8. Number 3, completely factor the difference of 2 squares. That's a clue, difference of squares. We have a square minus a square. When we factor a difference of squares, it becomes a sum and a difference. What is the square root of the first term? X. What's the square root of the second term? 9. So we have an x plus 9 and an x minus 9. And remember, I say in class over and over, when you factor, you can always check to make sure you got the right answer by foiling it back out. X times x is x squared. X times minus 9 would be a minus 9x for the outers. The inners would be a plus 9x. And then the last term times the last term would be a minus 81. And these middle terms, of course, would cancel. So we're left with x squared minus 81, and that is right where the problem started. So we know we factored it correctly. X minus 9, x plus 9. Now here we have, it says factor the perfect square trinomial. So this is a perfect square. This is a perfect square. We're going to have a binomial quantity squared. And then, of course, I want to check to make sure my middle term works. So, what is the square root of 9? 3. What's the square root of u squared? U. What is the square root of 16? 4. What's the square root of v squared? V. Since these signs are all pluses, we will have a plus here. Remember, whatever this sign is, you bring down. So that's a plus. And we want to check our middle term. Remember, the middle term is the first thing times the second thing times 2. Well, here our first thing is 3u, and we're going to multiply that by the second thing, 4v, and times that by 2. So if we multiply these together, we get 12uv times 2 is 24uv. So the middle term worked. This is the correct factorization of our original perfect square trinomial. On to the fractions, the fun stuff. Perform the operation and simplify. So we have a fraction minus a fraction. Remember, we cannot add or subtract without a common denominator. My common denominator is the 2 denominators that I have multiplied together. So I just take these, and I always parenthesize them off. I multiply them together for my common denominator, and I look at my numerator now. Here I have a term, or a constant, 4. So 4 times, remember, we want to multiply the numerator by what is missing below it. Here we have the 2x plus 1 piece of the common denominator. We're missing the x plus 2. So we're going to multiply 4 times the x plus 2. And then here we have minus x. Underneath the x, we have the x plus 2 piece of the common denominator, but we're missing the 2x plus 1. So there was the hard part. Now we're just going to distribute in the numerator and collect like terms, and we should be done. So distribute the 4. 4x plus 8. Distribute the minus x. Minus x times minus 2x is minus 2x squared. And minus x times 1 is minus x. And that is all over our common denominator. And finally, we just clean up that numerator by collecting like terms. Our denominator will not change. That is the quantity 2x plus 1 times x plus 2. In the numerator, we only have one squared term, and it's minus 2x squared. We have a minus x and a plus 4x. 4x minus x is plus 3x. And then we have a plus 8 at the end. And there's our final answer. Okay, and here in example 6, we have a multiply problem. And remember the big difference between multiply and dividing. If it's division, we just multiply by the reciprocal. But we don't have to worry about that on this one because it just is a multiply problem. We're going to factor it and multiply straight across. Okay, so when I look at this, see, probably the easiest thing to factor would be this numerator on the left. A square minus a square, x squared minus 16. That's going to factor down into a sum and a difference. So x plus 4 and x minus 4. All right, and when I look at this denominator here, well, let's wait for that a little bit later. Numerator on the right here, x squared plus x minus 90. We got a nice trinomial. My x squared term has to come from x times x. The factors of negative 90 that add up to positive 1 would be 10 and 9. And we want the 10 to be positive. So plus 10 and minus 9. And then down here below it, x squared plus 14x plus 40. We need the factors of 40 that add up to 14. It's going to be x and x. Our signs are both positive, so this is plus and plus. Factors of 40 that add up to 14 would be 10 and 4. And look, we've got something going on above and below here can cancel. The x plus 4 on the diagonal. Now this denominator, 9 minus x. We've seen a couple problems like this in class. We want 9 minus x to look like x minus 9. So if we have 9 minus x, and we factor out a negative, if we factor a negative out of this negative x, that turns it to a positive x. And this here is a positive 9. When we factor out a negative, that changes it to a negative 9. So factor out the negative, and then we flip those two terms. The x and the 9 trade places, but it still is a minus sign between them. And now it looks like a bunch of stuff can cancel. X plus 10, x plus 10. On the diagonal, x plus 4 here and here. X minus 9 on this diagonal. Now when you cancel this x minus 9 quantity, we're not canceling the negative that we factored out, so that still is in play. So let's see what we have left in across our numerator. The only term left is x minus 4. And our denominator, we have that negative, and we'd need something to hold its place, so a negative 1. That answer would be fine. Or, if we divide something by a negative 1, we just negate that term. So you'd need your x minus 4 in parentheses, but you'd have a negative out front. Or if you even went a little bit farther, maybe you distributed the negative x plus 4. I guess I could take any 3 of those on the test. And now on to distance and midpoint formulas. So this is a two-parter. Part A, find the distance between the points. Remember, the distance formula is x minus x, quantity squared, plus y minus y, quantity squared. So my x's, here I'm going to go, let's go left to right, or right to left. 5 minus negative 1. 5 minus negative 1. And the difference of the y's, y minus y, will be 4 minus 2. So, working in the parentheses, 5 minus a negative 1 is 5 plus 1, or 6. 6 squared is 36. Plus 4 minus 2 is 2. 2 squared is 4. And we can combine that and get root of 40. And what the heck, let's simplify that. What perfect square is hidden in 40? Well, 40 is 4 times 10. And the square root of 4 would come out. The square root of 4 is 2. 2 square root 10 would be the best answer for 7a. And now we want to find the midpoint between the two segments. Remember, a midpoint is just another point in the Cartesian plane. Our x-coordinate is x plus x divided by 2, and our y-coordinate is y plus y divided by 2. So now we're adding them. X plus x, 5 plus negative 1. Y plus y is 4 plus 2. So 5 plus negative 1 is 4. 4 divided by 2 is 2. And here we have 4 plus 2 is 6. 6 divided by 2 is 3. So if we were to graph the points, negative 1, 2, and 5, 4, and connect them with a line segment, right in the middle of that line segment would be this point, 2, 3. And that is the end of the practice test. So good luck on the test tomorrow.